Example 2, we want to draw the graph of the function f of x, which is equal to x squared plus 7x plus 3 over x squared, in a viewing rectangle that contains all the important features of the function. And we're going to estimate the maximum and minimum values and the intervals of concavity, and then use calculus to find these quantities exactly. So we're going to graph this function first, and then depending on what that looks like when we graph it, we may want to change the viewing rectangles. So I went ahead and did that on Desmos, okay? And so here you can see what the function looks like first. When we graph this function here on the left graph, you can see that it doesn't really give us a lot of information. Actually, the first graph is actually a disaster the way it looks right now. So we can't really kind of get any information from that graph. Now, some graphing calculators automatically use their viewing rectangle from -10 to 10 and -10 to 10 as a default viewing rectangle. So if we try that over here, going from -10 to 10 and -10 to 10, then we can see that there is a major improvement. Now we can also notice here that the y-axis possibly looks like a vertical asymptote, and actually it is. Okay, and by doing that, we can find the limit of that function. So if you want to find the limit of the function, and the limit as x is approaching 0 of x squared plus 7x plus 3 over x squared. Okay, so what do we get? We get the limit as x approaches 0 of x squared divided by x squared, which is 1, plus 7x divided by x squared is 7 over x, plus we have 3 over x squared, which is 3 over x squared. And so therefore that's going to give us infinity. So as x is approaching 0 from the left and right, we can see that there is a vertical asymptote at the y-axis. Okay, now let's also continue to look at number 2 here, graph number 2. So the second graph also tells us and allows us to examine the x-intercepts. So we have x-intercepts at -0.5 and -6.5, so you can see where the x-intercepts are. Okay, and the exact values are obtained by using the quadratic formula to solve the equation x squared plus 7x plus 3 equals 0, which is in the numerator, and we get x to be approximately -0.459 and -6.541. Okay, now we want to get a better picture of this, and so by getting a better picture, we want to look at the horizontal asymptote. So we change the viewing rectangle to be -20 to 20, and then from -5 to 10. And this is in the third figure. So it appears that y equals 1 is the horizontal asymptote that is easily confirmed. So you can see here, when this graph goes down here, it's going to get to, it's not going to go cross that value on the right side of the graph. So the horizontal asymptote is where y is equal to 1. Okay, so what we want to do now is we want to be able to confirm this by looking at the limit of this function. So if we take the limit and let x approach plus or minus infinity of the function x squared plus 7x plus 3 and divide that by x squared. So again, we're going to take the limit as x is approaching plus or minus infinity of 1 plus 7 over x plus 3 over x squared. Well, that gives us 1 plus 0 plus 0, which is equal to 1, which tells us that we have a horizontal asymptote at y is equal to 1. Okay, now we want to be able to estimate that minimum value here. Okay, so To estimate the minimum value, we zoom in here into the viewing rectangle where it's between -3 and 0 and -4 and 2 in the fourth figure. And so the cursor indicates that the absolute minimum value is at about -3.1 when x is approximately -0.9. So here we have the absolute minimum value, which we can see is here. Okay, and we see that the function is decreasing from -infinity to -0.9. So we can see that it is decreasing from here to there. So we know it's decreasing from -infinity to -0.9. And we also know that it's decreasing from 0 to infinity. And by that, we know if we look up here, we know that from 0 all the way to positive infinity, we know it's decreasing. Okay? And then where is it increasing? Well, it is increasing on -0.9 to 0. So here we can see that it's increasing from here okay, which means it's increasing from there. So the exact values are going to be obtained by differentiating. So if we want to differentiate, okay, the function, okay, so we know that f of x is equal to x squared plus 7x plus 3 over x squared, which is the same thing as x squared over x squared plus 7x over x squared plus 3 over x squared, which is the same thing as 1 plus 7x to the -1 plus 3x to the -2. Okay, so let's go ahead and find the first derivative. So we're going to get 0 minus 7x to the -2 minus 6x to the -3. So therefore, if we want to write out this function, it's going to be -7 over x squared minus 6 over x cubed. And if we want to find a common denominator, then we would end up with -7x minus 6 over x cubed for the first derivative. Okay, so let's go ahead and graph that. So when we graph that function, we can see here that here is the first derivative. And what do we notice? We notice that it's going to be, the first derivative is going to be greater than 0 when x is in between 0 and -0.86. So in between here and here, we see that it is greater than 0. Okay, and we see that the first derivative is going to be less than 0 when x is less than -0.86. So here we can see that it is less than 0, which is underneath the x-axis from there, and also it's going to be less than 0 when x is greater than 0. So you can see here it's going to be underneath the x-axis here. Okay, now what is the exact minimum value? Well, the exact minimum value is located at -0.86 with an output of -3.08, which on the function there is our exact minimum value. So the fourth figure up here also shows that there is an inflection point that occurs between -1 and -2. So we could estimate it much more accurately using the graph of the second derivative. So we are going to do that. So let's find the second derivative. So we know that the first derivative is equal to -7x to the -2 minus 6x to the -3. So the second derivative is going to equal 14x to the -3 plus 18x to the -4, which is the same thing as 14 over x cubed plus 18 over x to the 4th, and therefore this becomes 14x plus 18 over x to the 4th. So now let's take a look at this graph of the second derivative. So what can we look at here? So we can see that the second derivative is going to be above the x-axis or greater than 0 when x is greater than -1.29. So here we can see when x is greater than -1.29, we can see that this function is above the x-axis. Okay, so what that means is that it's going to be concave upward on the function. So it's going to be concave upward from -1.29 to 0. So we can see here that it's concave up from -1.29 to 0. And it's also going to be concave up from 0 to infinity. Okay, and we know that it's going to be concave downward from -infinity to -1.29. So therefore there is the concave downward from there. Okay, now the inflection point is -1.29 to -2.63. So here we can see that that represents the inflection point. So the analysis using the first two derivatives shows that the third figure displays all the major aspects of the curve.